The event that initiated the investigation began with the recording of a series of rhythmic pressure anomalies captured by the exterior sensors of a deep-range submarine operating at depths where no known biological organism could produce detectable surface impacts, and the anomalies manifested as distinct sequences of micropressure pulses arranged in a pattern consistent with footstep-like contact, though at depths exceeding any documented capacity for walking or crawling. Locomotion due to pressure conditions incompatible with jointed limb structures or mass-supported movement, and the readings were first dismissed as instrument noise until analysis revealed consistent spacing, intervals, and amplitude. Variations following a progression indicative of deliberate or mechanically structured motion, and these findings prompted a detailed review of the exterior hull recordings, which contained faint yet measurable vibrational signatures aligned with the pressure anomalies forming a pattern strikingly similar to the movements of an entity traversing the submarine's outer surface in a crawling progression, and the vibrational footprint demonstrated characteristics inconsistent with suction-based organisms or gliding locomotion typical of deep ocean life, instead showing discrete load points suggesting that multiple contact surfaces engaged sequentially as though an articulated structure exerted momentary pressure on the hull before shifting weight to an adjacent point. And this notion introduced a profound anomaly within existing biological models, which state that at such depths, the immense E, hydrostatic pressure prohibits limb-based locomotion on solid surfaces, as any structure capable of transferring weight would be crushed or immobilized by density forces. And yet the recorded pattern indicated not passive contact, but active movement with periodic accelerations and directional changes, suggesting that the source of the vibrations possessed not only mobility, but control over its motion, despite environmental conditions that should render such actions impossible. And further analysis detected that the pressure pulses exhibited minute but consistent delays correlating with the hull's curvature, implying that the entity adjusted movement to maintain contact across the submarine's external pulses geometry, demonstrating an awareness of structure, shape, or an adaptation, enabling it to trace surfaces without visual cues. And this level of coordination raised questions regarding whether the phenomenon was biological, mechanical, hybrid produced by extreme environmental conditions unknown to current science, and, as the data underwent spectral decomposition, researchers identified subtle frequency modulations accompanying each pulse, indicating internal resonance. Characteristics inconsistent with bone cartilage or known deep-sea exoskeletons, but displaying harmonic patterns more similar to mineral-reinforced structures, suggesting the possibility of an organism or mechanism composed partially of crystalline or pressure-stable materials, capable of functioning at abyssal depths without structural collapse, and advanced imaging arrays analyzed reverberation paths and discovered that the pulses propagated through the hull in a manner implying that the impacting structure had a density exceeding that of any documented marine organism, yet not so rigid as to produce brittle echo signatures typically associated with rock or metal collisions, indicating a composite material neither fully organic nor fully inorganic. And this paradox led researchers to consider whether the entity that traversed the submarine hull belonged to a class of deep ocean forms capable of integrating mineral components into their anatomical structure in response to high-pressure environments, similar to theories proposed regarding mineral-integrated organisms in previous anomalous discoveries and acoustic triangulation. Revealed that the footstep-like pattern migrated across the hull in a route that avoided sensor protrusions and structural irregularities, suggesting that the entity either perceived environmental gradients or possessed an innate ability to navigate three-dimensional structures through tactile or field-responsive mechanisms, allowing it to identify and circumvent obstacles in real time. And as analysts reconstructed the movement path, they noted an unnerving consistency in stride length and force distribution patterns, implying that the entity maintained a stable gait despite the lack of friction-friendly surfaces at depths where conventional locomotion should be impossible, and microindentation readings recorded at sensor contact points revealed that pressure differentials intensified at regular intervals, matching the timing of each external pulse, indicating that the source apply D. Controlled force at moments of contact, rather than merely drifting or adhering passively to the submarine surface. And this behavior suggested deliberate locomotion with intentional application of mechanical load, raising further questions regarding the nature of the organism's internal support structures, which would need to withstand pressures surpassing those required to collapse steel at similar depths. And as research progressed, the possibility emerged that the source of the footsteps may not have been a living organism in the conventional sense, but instead a pressure-adapted construct shaped by environmental mineralization processes in which biological templates are reinforced or replaced by crystalline matrices capable of resisting collapse under extreme oceanic pressures. And this hypothetical structure would allow for articulated movement despite environmental force constraints, raising the possibility that the crawling source represented an evolutionary divergence, relying on hybrid organic mineral architecture rather than classical soft tissue frameworks and data modeling, suggested that locomotion at such depths could be feasible if the organism possessed rigid, yet flexible mineral integrated limbs, capable of distributing force across contact points while maintaining internal structure through pressure, reactive materials, similar to theoretical pressure-actuated composites, and the spectral analysis of vibrational signatures further supported this theory, as frequency markers indicated the presence of layered materials with density gradients resembling multi-phase crystalline line structures capable of absorbing and redistributing pressure waves efficiently, allowing functional movement under conditions fatal to traditional anatomical models. And additional anomalies arose when researchers noted that the sequence of movements recorded on the hull corresponded to slight fluctuations in surrounding electromagnetic fields, implying that the entity's locomotion may have interacted with or been influenced by deep ocean field gradients. And this interaction suggested a possible sensory mechanism, or even a type of propulsion or stabilization system, involving environmental field coupling, similar to patterns observed in rare deep-sea energetic boundary events, though the mechanics behind such interactions remain unclear, and the entity continued its movement pattern for a duration of several minutes, gradually shifting position along the hull, and eventually descending beyond the submarine's range of sensors, leaving no physical residue, no visible marks, and no acoustic emissions, other than the recorded micro-impacts. Yet the effect on environmental readings persisted for several seconds after the movement ceased, suggesting a trailing disturbance akin to a fly-ash density wave collapse or field relaxation phenomenon. And this trailing effect offers further evidence that the entity possessed structural or energetic properties distinct from conventional marine life and capable of influencing local environmental conditions in ways uncharacteristic of organisms relying solely on biochemical processes. And as the movement sequence was reconstructed in slow-motion simulation, it revealed a disturbing regularity and precision incompatible with random drift or instinctive reactive movement, instead reflecting the kind of controlled progression associated with organisms capable of deliberate environmental exploration or mechanical structures optimized for external surface traversal. And this implication added a new dimension to the investigation, raising the possibility that the entity may be an apex organism in an environment previously considered biologically barren, or a naturally occurring hybrid system emerging from interactions between biological matter and deep ocean geophysical forces. And the absence of biological residue further contributed to the mystery, as even the toughest exoskeleton-bearing organisms typically leave microscopic traces when applying pressure to metallic surfaces. Yet the hull remained chemically pristine, suggesting either an inorganic contacting surface or a biological composition resistant to friction-based degradation, an attribute consistent with mineral-reinforced tissue structures. And as researchers expanded their analysis beyond immediate sensor data, they discovered that low-frequency hydroacoustic readings captured before and after the event contained faint echoes that matched the periodicity of the crawling sequence, though these echoes dissipated in patterns inconsistent with mechanical propulsion or fin-based movement, suggesting that the organism or structure did not swim, but instead manipulated density gradients to shift position, a behavior potentially related to the boundary propagation phenomena theorized in other D.P. ocean anomalies. And these findings prompted a re-examination of deep ocean movement models, proposing that certain entities may harness subtle buoyancy, modulation, or localized pressure field manipulation to reposition themselves rather than relying on muscular or mechanical actuation. And if the source of the footsteps employed such mechanisms, it would explain the absence of turbulence, footprints, acoustic emissions, or mechanical drag signals typically associated with biological movement. And as the conceptual framework surrounding the event expands, researchers confront the possibility that the detection of footsteps crawling across a submarine hull represents not isolated behavior, but part of a broader pattern of interactions between unknown deep ocean entities and human technology, suggesting that such interactions may have occurred previously, but were misinterpreted as sensor malfunctions or external noise due to the subtle and depressed, unconventional nature of these phenomena and the absence of visual confirmation further feeds the hypothesis that the organism's morphology may not conform to recognizably biological shapes, and instead may involve adaptive geometries, optimized for extreme pressure, mobility, mineral integration, and field responsiveness, making visual identification difficult, if not impossible, with traditional imaging tools. And as the analysis team compiles their findings, they recognize that the event raises profound questions not only about undiscovered marine species, but about the nature of biological evolution in extreme environments, about the possibility of mineral integrated life forms, and about the capacity of deep ocean ecosystems to support organisms whose method of existence diverges radically from the biochemical constraints that define surface life. And through this understanding, the footsteps recorded on the submarine hull become more than an anomaly. They become evidence that Earth's most inaccessible regions may harbor forms of life or quasi-life that operate under principles bridging biology, geology, and physics, and whose interactions with the environment demonstrate levels of adaptability and structural innovation previously considered impossible. And as researchers prepare to continue deeper investigations, the event stands as the first unambiguous sign that something in the abyss possesses the capability to traverse solid surfaces under crushing pressure conditions in complete darkness, leaving behind no biological trace and moving with deliberate precision across the hull of a vessel not designed to encounter anything walking at depths where walking should not exist at all. As the investigation into the unexplained footsteps recorded on the submarine's exterior advances, scientists begin to reconsider deeply rooted assumptions regarding the biological and mechanical limitations imposed by abyssal pressure and extreme environmental isolation, and the recorded sequence of impacts which demonstrates a conspicuous absence of turbulence, thermal anomalies, or acoustic propulsion markers becomes increasingly regarded as evidence of an entirely unconventional mode of locomotion, suggesting that the entity responsible may rely on geological or energetic mechanisms rather than muscular or hydrodynamic movement. And this realization prompts researchers to look beyond familiar evolutionary models towards scenarios in which living structures could arise not from organic pressure, adaptation alone, but from the integration of mineral frameworks, electromagnetic responsiveness, and pressure-induced phase stabilization, allowing organisms to operate structurally at depths where purely biological tissue would be crushed and rendered immobile. And supporting this emerging theory are the pressure wave recordings captured during the event, which reveal that each footstep-like impact exhibited not only localized force, but a faint peripheral modulation, indicating that the contacting structure possessed internal density gradients capable of flexing and adjusting in real time to maintain stability against the submarine's curved metallic surface, implying a form of intelligent material behavior akin to pressure-reactive composites seen in advanced materials science, though here arising naturally rather than through engineered design. And deeper analysis of the recorded resonance signatures reveals patterns that cannot be explained through known biological materials whose vibrational modes are limited by organic elasticity. Instead, the hull response to each impact exhibits harmonic layering, characteristic of crystalline or semi-crystalline structures capable of storing and releasing micro amounts of mechanical energy in response to environmental compression between each step, suggesting that the entity utilizes intrinsic mineralized component as part of its locomotion system, enabling it to create leverage even under near incompressible conditions, where standard joints and muscles would be functionally useless. And as researchers explore this idea further, they analyze the present action as in scapular spacing of the impacts, which remains astonishingly consistent regardless of hull curvature, indicating that the entity maintained a stride length, optimized for pressure distribution rather than limb flexibility, suggesting that its locomotor system may consist of repeating structural units capable of uniform expansion or contraction in response to pressure changes rather than discrete joints and bones. And such a configuration would resemble a segmented mineralized scaffold in 7 sed, which each segment acts as a pressure-modulated actuator, enabling controlled force application without the need for muscular tissue, and potentially explaining how the entity traversed the hull without succumbing to environmental constraints that prevent locomotion at depth. And this hypothesis gains credence when researchers simulate pressure conditions identical to those present during the event, and discover that only composite materials composed of mineral lattices interspersed with flexible amorphous layers can withstand the degree of mechanical repetition consistent with the footsteps recorded, implying that the organism, if biological, must incorporate mineral-based structural elements into its anatomy in a manner far surpassing known examples of biomineralization, and resembling instead a hybridized architecture where biological and geophysical components exist inseparably. And analysis of long-term hydroacoustic monitoring records from the same region reveals a previously unexplained series of low-amplitude repetitive pulses, extending back several years, which display a periodicity and frequency profile similar to the footsteps, suggesting that the crawling event may not be isolated and that the organism or organisms responsible may inhabit the region on an ongoing basis, regularly interacting with solid surfaces such as geological formations or submersible hulls using a method of tactile navigation and field alignment rather than typical sensory cues, and these pulses, when reconstructed spatially, form patterns reminiscent of linear and radial mapping behavior, implying the possibility that the organisms may utilize contact-based sensing to interpret environmental structures, navigating by applying periodic force against surfaces and interpreting the resulting vibrations, much like geological instruments, but in a biologically integrated manner, adapted over evolutionary timescales to function within the abyssal environment. And as speculative as this model appears, it aligns with the discovery that the footsteps were accompanied by micro-level electromagnetic field fluctuations, suggesting that each step did not simply apply mechanical force, but also interacted with ambient energy fields, possibly enabling the organism to stabilize itself or derive sensory input through field modulation, indicating that the creature's locomotion may be inseparable from its environmental awareness, and that every movement is part of a larger system of geophysical interactio, rather than independent muscle-driven action. And these findings prompt researchers to explore whether the organism's structure could include piezoelectric or pressure-responsive crystalline components capable of converting mechanical contact into electrical signals, granting it sensory capabilities far exceeding those of conventional deep ocean species, and allowing it to perceive environmental gradients, pressure distributions, and magnetic fluctuations as part of its locomotor strategy. And this concept shifts the investigation toward the possibility that the source of the footsteps may belong to a class of organisms that evolved not through classical biological adaptation, but through an extended interaction between organic matter and mineral fields, driven by the chemical and physical extremes of the deep ocean trenches. And if such a class exists, it may represent an evolutionary divergence in which life forms harness geophysical processes not merely as environmental constraints, but as integral components of their biological systems, enabling structures to exist that bridge the boundaries between organism and environment in a way fundamentally different from the familiar life. And researchers observing the timing sequence of the footsteps note that the impacts do not align with random exploratory behavior, but instead correspond to a repeating pattern suggestive of environmental scanning or, in structural assessment, as though the organism navigated across the hull to map its composition or interpret its presence within the surrounding field environment, using a combination of pressure, feedback, and electromagnetic sensitivity. And if such behavior is intentional, it suggests a level of environmental awareness beyond simple instinct or reflex, implying that the organism or structure is capable of perceiving complex physical data, and adjusting its behavior accordingly, which raises profound questions about the nature of cognition or pattern recognition in life forms that rely on mineral-integrated biological systems, and whether such systems could allow forms of intelligence or environmental interpretation, fundamentally distinct from neuronal processing in organic organisms. And as these questions grow, researchers widen their search to examine whether other submarines or deep-sea structures have encountered similar events. An archival review reveals that several classified mission logs contain vague descriptions of unexplained external tapping, scraping, or crawling sensations felt on the hull, though at the time these events were dismissed as thermal contractions, sediment impact, or equipment malfunction due to the absence of visual confirmation. And now, with new evidence, these historical reports appear consistent with the pressure patterns recorded in the current case, suggesting that such organisms may have interacted with human vessels multiple times, yet remained undetected due to their unconventional biological signatures and the rarity of appropriate sensor data and when these events are analyzed collectively. They exhibit strikingly consistent behavioral patterns, including approach, assessment, surface, traversal, and retreat, all conducted without causing structural damage, suggesting that the organism's interest in vessels may be exploratory rather than predatory. Though the motives remain speculative and may relate to field disturbances caused by the vessel's presence or curiosity about unnatural content. Environmental signatures introduced by human technology, and as researchers reconstruct a broader environmental context, they note that several of the historical incidents occurred during periods of increased tectonic activity or magnetic field instability, implying that the organisms may be more active or surface-oriented during episodes of geophysical fluctuation, and that their presence near human vessels could be incidental to larger-scale migratory or behavioral patterns linked to environmental rhythms deep within the oceanic crust. And this discovery prompts geophysicists to analyze whether the creature's movements correlate with pressure wave cycles emanating from fault lines, hydrothermal upwellings, mantle plume oscillations, and indeed several correlations emerge, indicating that the organism may navigate in harmony with geophysical forces using periodic energy releases as environmental guides, enabling movement across large distances with minimal energy expenditure in a manner profoundly divergent from typical metabolic locomotion. And this understanding leads to the hypothesis that the entity may exist within a unique ecological niche, where it derives sustenance not from traditional organic sources, but from energy differentials within the deep ocean's pressure, electromagnetic, and seismic environment, effectively functioning as a living resonant body tuned to the planet's geophysical rhythms. And this concept aligns with the strange precision of the footsteps as a structure, relying on resonance and field interaction, would traverse a submarine hull not as prey or obstacle, but as an anomalous field object to be examined as part of the organism's sensory or environmental mapping processes. And if such organisms inhabit Earth's deepest regions, their presence may influence deep ocean geophysical dynamics in subtle, yet significant ways, shaping pressure distributions, mineral deposition, and vibrational propagation patterns, potentially contributing to geological stability or influencing environmental oscillations that previously lacked explanation. And those implications inspire new scientific inquiries, asking whether deep ocean ecosystems may include not just organisms adapting to environmental conditions, but organisms whose existence actively shapes those conditions through interactions between biological resonance structures and geophysical forces. And such a possibility fundamentally redefines the concept of life as an isolated biological process, and instead portrays it as an emergent phenomenon shaped by synergy between organic and physical systems, giving rise to forms that challenge the boundaries of evolutionary theory and expand the scope of what biological entities may be capable of achieving under extreme environmental pressures. And as researchers prepare extensive follow-up missions equipped with enhanced field sensors, deep resonance imagers, and pressure-adaptive recording systems, they acknowledge that the footstep it's recorded across the submarine hull represent the first tangible evidence of a form of life or life-analogous system that merges biological and geophysical principles to create functional structures capable of withstanding and maneuvering within depths previously believed to be void of complex organismal activity. And this discovery opens the possibility that unknown organisms inhabit not only the open water, but the very surfaces of geological formations interacting with crustal forces and environmental rhythms in ways that blur the line between biological adaptation and planetary function. And through this understanding, the mysterious footsteps transform from an isolated anomaly into a window revealing a hidden biome of mineral-integrated resonant organisms whose existence challenges assumptions about life, the deep ocean, and the interaction between matter and biological structure, and begins reshaping scientific frameworks to accommodate the possibility that Earth harbors not one biosphere, but multiple layered biosystems, each adapted to environments so distinct that the rules governing life in one realm cannot be universally applied to the others. And with this recognition, the footsteps become the first recorded contact between humanity and entities whose biology may reflect the fundamental forces of the planet itself, moving unseen through the darkness, pressing their weight against human machinery, and then disappearing into the abyss, leaving only faint vibrations to suggest their passage. As the global scientific effort intensifies and the clues revealed by the anomalous footsteps accumulate into a coherent, though entirely unprecedented body of evidence, the investigation shifts from local phenomenon analysis toward the broader context of how such an event could fit within the deep ocean's geophysical and biological architecture. And researchers from oceanography, geophysics, astrobiology, materials science, and theoretical biology begin constructing integrative models describing environments so extreme and isolated that they may foster entirely different evolutionary trajectories, giving rise to organisms whose structural and functional principles diverge radically from those observed in shallower ecosystems. And within this emerging paradigm, the crawling motions recorded on the submarine hull cease to be interpreted as isolated aberrations and instead form part of a larger pattern of deep ocean interactions, in which unidentified entities appear capable of locomotion, sensory perception, and environmental engagement through mechanisms involving pressure, resonance, mineral-integrated structures, and electromagnetic field coupling, suggesting that such organisms do not merely survive in the abyss, but thrive within conditions too severe for standard biology to operate. And as this understanding deepens, scientists re-examine environmental readings from the time of the encounter, noting that the footsteps occurred during a brief dip in local electromagnetic stability, combined with a subtle increase in ambient pressure fluctuations, likely caused by minor tectonic 40 MAD adjustments in nearby subsea fault lines, and these conditions appear to correlate with periods of HEI, heightened geophysical resonance, enabling structures capable of field-based sensory navigation to interpret environmental signatures with increased clarity, possibly drawing such organisms toward anomalous objects such as the submarine, whose metallic surfaces generate distinctive field disruptions not present in natural environments. And this alignment between environmental disturbance and biological response suggests that the organisms may navigate by perceiving distortions in geophysical fields, allowing them to detect geological activity, mineral deposits, and other large structures by interpreting the propagation patterns of ambient energy, rather than relying on optical or acoustic cues. And this theoretical framework is strengthened by analysis of the pressure signatures recorded during the event, showing that each step corresponded with microshifts in ambient density aligned with the natural resonance of the surrounding water column, indicating that the organism could manipulate or respond to pressure gradients with remarkable precision, enabling it to anchor itself temporarily against the hull and shift its weight deliberately without creating turbulence or structural deformation. And such behavior requires an anatomical configuration fundamentally different from fin locomotion or muscular articulation, suggesting instead a body plan composed of pressure-reactive mineral matrices capable of momentary rigidity and controlled release, enabling limbs or appendages to function in a manner that defies the limitations of compressible organic tissue. And further supporting this hypothesis is the discovery that the vibrational signatures exhibited decay curves inconsistent with protein or chitin-based structures, instead resembling those produced by layered crystalline composites, where alternating hard and flexible mineral phases dissipate mechanical energy efficiently under extreme compression, allowing durable and repeatable motion even at pressures capable of collapsing submarines. And these structural interpretations align with models predicting that Mineral-integrated organisms could evolve in deep ocean trenches where mineral deposition, electromagnetic oscillation, and pressure cycles combine to form environments favoring adaptive architectures in which biological tissues incorporate geophysical materials to withstand and exploit extreme conditions. And as researchers incorporate these findings into evolutionary analysis, they begin proposing that the deep ocean may host multiple ecological domains not reflected in shallow ecosystems, including geophysical symbiotic environments where organisms interact with tectonic processes, hydrothermal flows, and electromagnetic fluctuations in a dynamic interplay that shapes both their biology and the surrounding environment. And this perspective forces a reassessment of the deep ocean, not as a passive region of Earth, but as an active biological-geological interface, where life may influence geophysical stability by redistributing mineral loads, altering pressure fields, or modifying vibrational pathways in subtle yet continuous ways. And if such organisms exist in substantial numbers, they could play a role in maintaining long-term equilibrium within the deep ocean crust interface, modulating energy transfer between geological structures and the hydrosphere through their movement-feeding behavior or resonance activity. And as the investigation expands, researchers begin analyzing unusual patterns in long-term deep ocean vibrational data, discovering that certain trenches exhibit periodic disturbances previously assumed to be geological noise, but which upon reanalysis display rhythmic structuring, consistent with possible large-scale biological activity. And these rhythmic disturbances align uncannily with patterns expected from large mobile entities interacting with geophysical energy gradients, suggesting that the organisms responsible for the footsteps may be part of a broader population inhabiting extreme depths and potentially migrating according to tectonic rhythms, seasonal chemical fluctuations, or electromagnetic cycles. And if such migratory behavior exists, it may explain why encounters with these entities remain rare and unpredictable, as they may surface or approach submersible regions only during specific windows, when environmental conditions align to support surface-crawling sensory mapping or field-based navigation. And these findings prompt further modeling of the organism's potential biological role, with some researchers hypothesizing that the creature may participate in a form of mineral harvesting or energy extraction, wherein crawling across surfaces allows it to draw structural information about the surrounding field environment, enabling it to identify areas of high mineral concentration. Dynamic energy flow, essential for its sustenance, and such behavior would resemble no known feeding strategy, but could reflect an entirely unique method of resource acquisition rooted in geophysical rather than organic ecosystems. Supporting this idea are anomalies detected in mineral distribution maps of trench regions, showing small, localized areas where crystalline deposits appear disrupted or rearranged in patterns that do not match natural geological processes, yet could align with repeated contact by mineral-reinforced appendages exerting focused mechanical pressure over long timescales, indicating that such organisms may leave geological signatures that have gone unrecognized as biological due to their resemblance to tectonic microfractures. And further inquiry into the footsteps sequence reveals a distinct hesitation pattern in which the organism paused at several points corresponding to major structural transitions in the submarine hull, such as changes in curvature or material composition, suggesting that these transitions triggered sensory feedback, prompting the organism to reassess its path, possibly interpreting variations in resonance or electromagnetic signaling emanating from the internal systems of the vessel. And this momentary assessment behavior indicates not only environmental awareness, but adaptive locomotion strategy, implying that the organism possesses a sophisticated sense of its surroundings, capable of distinguishing between natural and artificial structures by interpreting their vibrational and electromagnetic signatures. And as these insights accumulate, the scientific community becomes increasingly convinced that the organism responsible for the footsteps belongs to a lineage adapted to deep oceanic conditions through a hybrid biological geophysical architecture, enabling it to interface with the planet's energetic systems in ways previously unimaginable, featuring limbs capable of acting as pressure actuators, sensory receptors, and energy transducers, all integrated within a single mineral-reinforced biological framework. And this sophisticated integration raises questions about the potential for cognitive functions in such organisms as the complex pattern recognition required for navigating structures, interpreting field variations, and adjusting movement. Behavior may indicate a level of intelligence or environmental modeling distinct from neural-based cognition and potentially reliant on distributed processing across mineral biological networks within the body, enabling real-time response to environmental fluctuations without reliance on a centralized brain structure. And these possibilities prompt new investigations into alternative forms of biological intelligence, wherein cognition emerges not from neurons, but from physical interactions between energy fields, pressure regimes, and mineral matrices, resulting in decision-making processes governed by resonance, harmonics, and field gradients rather than electrochemical signaling. And if such cognition exists, it represents a form of intelligence, fundamentally alien to surface biology, yet fully adapted to the unique constraints of the deep ocean environment, suggesting that complex life may arise in many forms, so long as environmental pressures guide the evolution of structures capable of interacting with local energy sources and processing information through unconventional pathways, and as researchers compile these findings, they confront the profound implications of their conclusions, recognizing that the organism's existence implies the presence of an entire biome hidden within Earth's deepest regions, evolving not through competition for organic resources, but through interactions with geophysical forces, and that these organisms may have existed for millions of years, undetected by human scientific frameworks, due to their lack of traditional biological signatures and the extreme isolation of their habitat. And this realization reshapes the scientific perception of Earth's biosphere, suggesting that life is not limited to a single biochemical architecture, but instead may develop in multiple parallel forms, each shaped by the environmental constraints of its domain, and that the organism responsible for the footsteps represents the first direct physical contact with the domain of life built upon geophysical integration rather than organic adaptation, and as exploration missions prepare to descend into deeper regions, armed with advanced field coupling sensors, resonance imaging technology, and pressure-stabilized observation platforms, the scientific community recognizes that encountering such organisms visually may still prove extremely difficult, as their structural integration with mineral matrices may render them indistinguishable from geological features and their evenness. Field-based locomotion may produce signatures easily masked by environmental noise, requiring new detection methods that treat biological activity as a function of energy redistribution rather than optical or acoustic presence. And the final report on the incident concludes that the footsteps recorded across the submarine hull represent definitive evidence of a large, deep ocean entity, employing pressure, stable mineral, integrated appendages, and field-responsive sensory mechanisms to navigate and interact with solid surfaces at depths previously considered incompatible with articulated locomotion. And the investigation asserts that the organism's movement pattern, resonant footprint, and environmental impact could not have been produced by any known biological or mechanical system, and that the phenomenon must therefore represent an entirely unknown form of life or life-analogous system adapted to the extreme geophysical environment of Earth's abyssal zones. And though the identity, morphology, and behavior of the organism remain beyond direct observation, the accumulated data forms an irrefutable foundation supporting the existence of deep ocean species whose biology merges seamlessly with the physics of the seafloor, creating entities capable of locomotion, sensory feedback, and environmental interaction through mechanisms that challenge the very definition of life and extend it into realms shaped not by sunlight and organic chemistry, but by pressure, darkness, and the planet's internal rhythms. And as humanity prepares to explore this hidden world, the footsteps on the submarine hull stand as the first acknowledged contact between two vastly different biological paradigms, signaling the beginning of a new era in understanding the deep ocean, not as a biological desert, but as a frontier of complex and integrated life forms, waiting to be revealed through technologies and theories still emerging in the wake of this profound discovery. Following the formal conclusion of the investigation into the unknown entity whose footsteps traversed the submarine hull, an extended research phase was initiated to analyze long-term environmental signatures across multiple deep ocean regions where similar anomalies may have occurred unnoticed. And this phase revealed extensive correlations between historic sensory irregularities and the behavioral characteristics inferred from the hull event, indicating that the organism's presence may not be localized to a single trench system, but distributed across various abyssal zones, exhibiting patterns of movement and environmental interaction consistent with a widespread ecological niche adapted to geophysical gradients rather than biological trophic chains. And these findings prompted a global reassessment of deep ocean monitoring archives, revealing that many pressure oscillations, magnetic drifts, and unexplained hull contact events, previously dismissed as equipment malfunctions, align with the predicted locomotion sequence of a mineral-integrated resonant species capable of manipulating its structural density in coordination with external fields, allowing it to maintain cohesive movement under intense pressure conditions. And further analysis suggests that the organism's interaction with the submarine may have been triggered not by curiosity, but by perturbations in field topology generated by the vessel's hull and propulsion systems, which produce vibrational harmonics and electromagnetic irregularities, detectable at long distances, and interpreted by the organism as either geophysical anomalies requiring assessment or environmental signals, indicating structural instability within the surrounding terrain and intractability. In this framework, the footsteps become a form of diagnostic exploration, as the creature assessed the artificial surface using limb-based resonance and pressure feedback to interpret the structural properties of the vessel, much as it would by assess geological formations, potentially using these interactions to map energy pathways or identify fault line activity in its native habitat. And this perspective suggests that the organism's biology may incorporate roles analogous to geological sensors or stabilizers, functioning as naturally evolved components of the deep ocean's dynamic equilibrium system, constantly monitoring and responding to variations in pressure, seismic activity, and electromagnetic gradients to maintain environmental stability. And these concepts introduce a provocative hypothesis that mineral-integrated deep ocean organisms may participate in regulating geophysical processes at micro and macro scales, subtly influencing sediment, displacement, vent field distribution, and resonant oscillation patterns through their continuous interactions with the seafloor and water column. And if true, such organisms may resent evolutionary solutions to maintaining environmental balance within high-pressure ecosystems, where geological instability poses ongoing existential risks, and biological systems adapt to mitigate these risks not merely for survival, but as part of a larger ecological coevolution between life and the planet's internal dynamics. And as researchers pursue this line of inquiry, they identify long-term correlations between regions showing frequent anomalous pressure signatures in areas with reduced tectonic variability, suggesting that the movement patterns of these organisms may contribute to redistributing localized stress along fault boundaries, functioning as pressure dampening agents. Physical interactions reduce the likelihood of abrupt seismic events, though the mechanisms remain speculative and require further study using enhanced field sensors and deep geophysical mapping arrays. And these correlations provoke new questions about whether such species evolved in tandem with Earth's geological cycles, developing adaptations that allowed them to survive and thrive in the most volatile environments by integrating their biology with the planet's natural rhythms, and whether these adaptations may have influenced geological processes over evolutionary timescales, contributing to stabilization patterns unnoticed, until advanced sensor technology became capable of detecting their long-hidden environmental signatures. And as theoretical models expand, scientists begin to consider whether such organisms may also influence global chemical cycles by redistributing mineral content acro. SS, the ocean floor, interacting with hydrothermal systems and shaping the composition of deep ocean water masses through sustained contact with high-pressure mineral deposits and crystalline substrates, creating chemical gradients, or circulation pathways previously attributed solely to geological activity. And these possibilities suggest that the deep ocean biosphere may be far more interconnected with Earth's interior systems than previously recognized, functioning as both a reservoir and regulator of planetary processes, integrating biological and geological mechanisms into a self-sustained dynamic architecture, extending from the upper mantle to the abyssal plains. And if this architecture indeed depends on the presence of large mineral integrated resonant organisms, Then their discovery marks not merely a biological milestone, but a revelation of Earth's internal ecological design, wherein life does not simply adapt to extreme conditions, but also shapes and stabilizes them in continuous feedback cycles, essential for planetary equilibrium. And as researchers continue compiling data, they identify subtle rhythmic fluctuations in deep ocean electromagnetic fields that appear time synchronized across multiple trench systems, suggesting a form of long-distance environmental coupling, possibly facilitated by the organisms themselves, using field resonance to coordinate movement behaviors, feeding patterns, or habitat. Shifts across large geographical areas, indicating a level of collective environmental interaction that transcends individual behavior and resembles ecosystem-scale synchronization BOS. And not on light or temperature cycles, but on geophysical oscillations spanning thousands of kilometers. And these findings challenge fundamental assumptions about the isolation of deep ocean environments, implying that even the most remote abyssal systems may be interconnected through organisms capable of sensing and responding to field fluctuations in near real time, forming a planetary network embedded within the Earth's interior rhythms. And these organisms may act as both inhabitants and agents of those rhythms, interpreting field disturbances and pressure anomalies as sensory information and adjusting their locomotion accordingly. And this realization provides new context for the footsteps on the submarine hull, suggesting that the vessel's presence may have introduced local field disruptions, triggering the organism's investigative behavior as part of its natural environmental monitoring patterns. And this interpretation reveals a new perspective in which human technology inadvertently enters the communication and sensing domain of an organism whose biology is synchronized with geophysical forces rather than visual or auditory stimuli, leading to interactions that appear anomalous from the human perspective, but natural from the organism's perspective. And as more research builds upon this framework, scientists begin exploring whether similar organisms may have existed throughout Earth's geological history, shaping sediment distribution, influencing tectonic stability, and modulating chemical gradients in ways not previously attributed to biological activity, suggesting that the plane T's evolutionary narrative may include long, hidden biological components integrated into deep Earth processes far older than surface evolution records imply. And these insights extend into astrobiological discussions, proposing that mineral integrated resonant organisms may represent a viable model for life on other planetary bodies where high-pressure environments lack sunlight, and traditional biochemical energy sources yet provide abundant geophysical energy and mineral substrates capable of supporting hybrid biological physical systems parallel to those theorized on Earth. And this leads to the recognition that the discovery of the footsteps and the inferred organism responsible may serve as a template for identifying extraterrestrial life signatures not through organic biomarkers, but through anomalous, vibrational, electrochemical, or field-based disturbances indicative of mineral-biological interaction and environmental resonance. And within this broader context, the submarine event becomes a landmark case, demonstrating that life can evolve intelligence, like environmental awareness and complex locomotion, without relying on traditional biological structures, and instead, through the integration of mineral frameworks and geophysical field sensing, enabling functionality unimaginable within classical biological architectures. And as the extended report reaches its final conclusions, it states that the footsteps represent not only the presence of an unknown entity, but the first direct evidence of a deep ocean biosphere operating along principles divergent from known biology and inseparably intertwined with the Earth itself, wherein organisms inhabit not merely a physical habitat, but a dynamic geophysical system whose forces serve as both environment and metabolic foundation. And that understanding such life requires abandoning surface-centric assumptions and embracing a model in which biology, geology, and physics merge into a unified spectrum of possible living systems. And the report asserts that humanity has likely only glimpsed a fraction of this hidden biosphere, and that future explorations equipped with field resonance detectors, pressure adaptive imaging, and mineral integrated biological sensors may reveal a world of astonishing complexity residing in the darkness below sculpting, and shaped by the planet's deepest rhythms. And the footsteps on the submarine hull stand as the unmistakable herald of that discovery, marking the first moment in which the unseen inhabitants of the abyss made their presence known through a pattern of movement that defied all expectations and opened an entirely new chapter in the understanding of life on Earth. In the months following the publication of the extended epilogue and the initial scientific consensus that the footsteps recorded on the submarine hull represented the first confirmed interaction with a class of mineral integrated resonant organisms, a series of multinational research initiatives began deploying long-duration sensing arrays across one of the sensings, deep ocean trench systems, resulting in a steady accumulation of environmental anomalies that both supported and expanded the emerging theoretical framework. And, as these anomalies underwent systematic comparison across variable geographic regions, researchers discovered strikingly consistent resonant activity signatures recurring at intervals suggestive of migratory behavior, seasonal modulation, or geophysical synchronization, indicating that the entities responsible may operate according to large-scale environmental cycles tied to pressure oscillations, electromagnetic drift, and mantle wave propagation patterns. And these findings presented the strongest indication yet that the organisms form part of a globally distributed system integrated with Earth's geophysical processes, and that their movement patterns are neither random nor purely localized, but instead appear influenced by deep mantle resonance pathways, mapping field gradients with extraordinary precision and responding to long wavelength tectonic rhythms that propagate across oceanic plates in predictable cycles. And when researchers constructed composite maps of these anomalies, they revealed distinct migratory corridors tracing along subduction zones, mid-ocean ridges, and fault junctions, which together form a network of geophysical pathways offering environmental conditions optimal for mineral integrated organisms, including abundant crystalline substrates, stable resonance harmonics, and sustained electromagnetic variability, essential for their sensory and locomotor functions. And as data density increased, analysts recognized that these corridors correspond closely with regions historically associated with unexplained acoustic distortions, pressure waves, and anomalous hull interactions, lending retrospective support to the hypothesis that the organisms have long been active in these areas, yet remained undetected due to the subtlety of their signatures and the inadequacy of earlier technological systems to interpret field-based biological interactions. And this correlation between modern detection and historical anomaly catalogs provided compelling evidence that the organisms represent not a rare aberration, but a persistent and ecologically significant component of the deep ocean environment whose presence spans continents and whose population size may be far greater than initially assumed, though distributed across vast pressure zones and synchronized with slow-moving geophysical rhythms rather than clustered as in conventional ecosystems. And as modeling efforts progressed, scientists began investigating how such organisms might reproduce, maintain population stability, and transfer biological patterns across generations in the absence of classical genetic systems. And these inquiries revealed the possibility that mineral integrated organisms may utilize environmental resonance fields as templates for structural formation, allowing developing individuals to adopt anatomical configurations and functional harmonics directly shaped by the surrounding geophysical environment rather than inherited through inherited biological molecules. And if this is true, then the organisms may not rely on DNA or RNA in tellurine, a conventional sense, but instead employ mineral lattice propagation and field-encoded patterning to maintain species continuity, resulting in a mode of evolution governed by environmental forces and energy structures rather than genetic mutation and natural selection in the traditional biochemical context. And such a mechanism would allow rapid adaptation to geophysical changes, enabling locally emergent variations in morphology or locomotion that mirror shifts in pressure gradients, mineral distribution, or field cycles, embedding environmental conditions directly into the organism's structural matrix and creating a living system that continuously co-evolves with the planet's deep dynamic interior. And this concept gains further weight from evidence of distinct regional variations in resonance signatures associated with different trench organisms, suggesting environmental tuning rather than biological lineage divergence, and raising the possibility that the organisms embody a form of biological modularity in which structural and functional elements assemble according to resonant compatibility with the immediate habitat, enabling diverse morphologies to arise from shared fundamental principles of mineral integration and field responsiveness. And if confirmed, this would represent one of the most profound discoveries in the history of biology, demonstrating the existence of life that does not evolve through genetic inheritance, but through geophysical imprinting, with each organism shaped directly by the energetic conditions of the environment in which it forms. And as researchers explore this paradigm further, they uncover additional lines of evidence supporting environmental imprinting, including highly localized patterns of mineral crystal orientation in samples retrieved from areas near known resonance anomalies, suggesting the influence of biological activity on mineral structures and vice versa, producing hybrid systems where environment and organism cannot be meaningfully separated as distinct components. And these findings compel scientists to consider that the organisms themselves may influence geophysical processes through their presence, with each individual acting as a node within a vast planetary network, redistributing mechanical energy, stabilizing pressure fields, and altering local resonance harmonics, thereby contributing to the long-term regulation of tectonic and hydrothermal systems in ways not previously attributed to biological agents and such. Interactions may not be intentional, but emergent properties of the organism's natural activities with their mineral integrated bodies acting as conduits through which environmental forces flow and dissipate, blending biological behavior. With geophysical mechanics in a unified continuum, and further examination of deep ocean pressure wave records reveals periods of synchronized activity across multiple trench systems, during which resonance anomalies intensify then stabilize, in patterns that appear too coordinated to be geological coincidences, and instead reflect the simultaneous presence or movement of large numbers of the organisms responding collectively to global geophysical fluctuations such as shifts in mantle convection or magnetic field drift. And this synchronized behavior implies a form of distributed communication or environmental coupling, enabling the organisms to detect and react to geophysical changes at planetary scale and adjust their movement or activities accordingly, functioning not as isolated individuals, but as components of a system-wide network governed by the Earth's internal rhythms. And as the scale of this network becomes clearer, researchers begin to reinterpret previously misunderstood geophysical events, such as episodic, deep ocean tremors, low-frequency hums, and unexplained resonance plateaus, proposing that at least some of these may be manifestations of collective organismal movement, energy redistribution, or entire population shifts, driven by field alignment or migratory triggers. And this perspective leads to the startling conclusion that certain long-observed geophysical signals traditionally attributed solely to mantle dynamics or seafloor deformation may instead represent blended signatures of biological and geological processes interacting in complex feedback systems where the organisms serve as intermediaries, regulating or responding to the energy flux within the deep Earth. And with this realization, scientists recognize that the footsteps recorded on the submarine hull represent merely the smallest detectable instance of a phenomenon operating on scales orders of magnitude larger than previously imagined, involving countless organisms across global trench systems engaged in resonant mobility and geophysical interaction as part of a planetary architecture, still only partially understood. And as research continues, interdisciplinary teams attempt to model how such organisms might influence the stability of the oceans and crustal bound areas under differing geological scenarios, and early simulations suggest that their presence may mitigate the propagation of certain deep seismic waves through absorption or redirection of vibrational energy, and may slow the growth of localized pressure instabilities by distributing mechanical force across wide areas through coordinated movement or environmental interactions, suggesting that the organisms may play a stabilizing role within trench systems, acting as costing natural buffers against extreme geophysical fluctuations. And if this stabilizing function is inherent to their biology, then the discovery has implications that extend far beyond taxonomy, indicating that Earth's long-term geological behavior may have been co-shaped by biological processes for millions of years, through a hidden biosphere that subtly moderates the planet's most extreme environments, contributing to the stability of the crust, hydrosphere, and possibly even the global magnetic field through consistent interaction with energy gradients in the deep ocean. And as these possibilities become more widely accepted, the original submarine event is increasingly seen not merely as a biological encounter, but as the first acknowledged moment in which humanity intersected with a planetary system that had operated unseen since long before human civilization existed, and that the vibration of footsteps across the hull represented not the Teveresh, the presence of a solitary creature, but the whisper of an enormous unseen network moving in harmony with the Earth itself, and the realization that such organisms exist and operate in ways, parable from the planet's deepest forces transform scientific understanding of Earth's biosphere, compelling a shift from a view of life as surface, centered toward a recognition that life extends into the most extreme reaches of the planet. Bridging organic biological processes with the physics of the Earth's interior, and as exploration continues, scientists acknowledge that the initial footsteps remain the only direct physical signature yet detected by human sensors, and that the full nature, morphology, and behavior of the organisms remain undisclosed within the darkness and pressure of the abyss, waiting for technologies not yet invented to reveal their true form and full significance, and thus the submarine event stands not as a closed chapter, but as the inaugurating record of a discovery whose impact will unfold across decades as humanity uncovers and begins to understand the vast network of mineral-integrated resonant life forms that inhabit and perhaps help regulate the deepest structures of the planet, existing at the threshold where biology becomes geology, where motion becomes resonance, and where footsteps in darkness reveal a world previously hidden from all human knowledge. In the aftermath of the growing consensus that an extensive and previously undetected class of mineral-integrated resonant organisms inhabits Earth's deepest trench systems, scientific efforts intensified toward understanding the potential long-term interactions between these entities and the large-scale processes governing planetary structure, stability, and environmental evolution. And as the volume of elected geophysical and hydroacoustic data expanded beyond initial survey boundaries, patterns emerged indicating that the presence of resonant organisms may correlate not only with localized pressure stabilization, but also with long-duration fluctuations in deep mantle convection cycles, suggesting that these biological systems may play a subtle yet continuous role in dissipating energy across the crust-mantle boundary, acting as dynamic buffers that redirect vibrational forces through distributed locomotion and collective resonance activity. And this possibility opened a new field of inquiry, exploring whether certain geophysical anomalies, long assumed to result from mantle heterogeneity, complex fault geometries, may instead partially derive from the migratory patterns or collective oscillatory behavior of deep ocean organisms, whose synchronized resonance could theoretically alter the propagation characteristics of seismic waves by absorbing specific frequency bands and redistributing energy across broad regions through their mineral-integrated bodies, functioning as natural resonant baffles embedded within the hydrosphere crust interface. And further, supporting this hypothesis are newly analyzed data sets showing that several historically perplexing seismic attenuation zones coincide precisely with regions where sensor arrays have detected persistent low-frequency harmonic signals, matching predicted biological resonance patterns, suggesting that the organisms may modulate geological energy transfer in ways that reduce the likelihood of abrupt fault ruptures by dispersing vibrational energy across time and space through their coordinated movement cycles. And if validated, this would indicate that the organisms have contributed to geological stability for vast periods, shaping the evolution of Earth's seismic landscape through continual interactions between biological resonance networks and tectonic forces. And deeper analysis reveals that the frequency signatures associated with these organisms exhibit subtle long-term drift patterns that align with changes in Earth's magnetic field, providing indirect evidence that the organisms may also be sensitive to geomagnetic fluctuations and potentially utilize them as environmental cues for navigation, collective alignment, or energy harvesting, enabling them to respond adaptively to shifts in the planet's internal dynamics and maintain consistent behavioral patterns across geological timescales. And this revelation leads scientists to explore whether the organisms might have influenced long-term magnetic field behavior by functioning as distributed conductors, anchoring and redistributing electrical charge in high-pressure mineral-rich environments, where seawater conductivity and crystalline structures facilitate complex electromagnetic interactions, and although highly speculative preliminary models demonstrate that mineral-integrated biological networks could theoretically modulate microscale electromagnetic flux by altering ionic pathways during locomotion or structural resonance, and that aggregated effects of large populations may contribute to smoothing or amplifying localized magnetic variations in trench S. Systems, though the extent of such influence remains uncertain and requires significantly more data before any definitive conclusions can be drawn. And as interdisciplinary teams delve deeper into these possibilities, they examine the space hypothesis that the organism's locomotion across solid surfaces, such as the submarine hull, may represent only one expression of a much larger behavioral repertoire involving interactions with mineral substrates, hydrothermal conduits, tectonic fissures through which the organisms may channel or redistribute energy not only for their own biological needs, but as part of a broader ecological role within the deep ocean geophysical environment. And these interactions could include pressure-induced realignment of mineral layers, selective removal or deposition of crystalline materials, and modulation of hydrothermal vent flow through the displacement of sediments or the creation of temporary microchannels, enabling the organisms to alter local temperature gradients, chemical concentrations, and field conditions as part of their ecological strategy. And if these behaviors exist, they may explain certain puzzling hydrothermal plume phenomena, including sudden changes in vent output inconsistent with underlying geothermal structures, which could reflect the activity of organisms shifting mineral deposits or altering pressure dynamics to either access energy sources or stabilize environmental conditions favorable for their continued presence. And these insights prompt a reconsideration of long-term hydrothermal variability records, which, when re-examined, reveal IC disturbances consistent with biological rather than purely geological modulation, indicating the possible presence of organisms interacting continuously with the vent systems and shaping their behavior over decadal and century-long cycles. And this leads researchers to hypothesize that the organisms may form the core of a deep ocean energy regulation system, acting not only as environmental stabilizers, but also as intermediaries in the transfer of energy between the subordinated mantle and hydrosphere, thereby influencing ocean chemistry, nutrient flow, and even global carbon cycling processes through sustained interaction with mineral systems that sequester or release chemical compounds under extreme conditions. As this framework solidifies, scientists begin researching whether the disappearance or decline of such organisms over geological timescales might have contributed to periods of increased tectonic volatility or altered ocean chemistry, suggesting that the health and distribution of the resonant organism population may be directly linked to planetary stability and environmental evolution in ways not previously considered. And this recognition expands the potential implications of the first detected footsteps across the submarine hull, elevating the encounter from a biological curiosity to a signal indicating that the functioning of Earth's deep interior and its biosphere may be more tightly coupled than any previous model allowed, and that life and geology are not isolated domains, but components of a single, intertwined system, whose behavior emerges from continuous feedback between living and non-living processes. And as scientists continue synthesizing available data, they uncover additional correlations between long-duration magnetic drift cycles and periods of increased deep ocean resonance activity, further suggesting that the organism's energy harvesting or communication mechanisms may be sensitive to variations in the geomagnetic field, which could influence their migratory patterns, energetic efficiency, or collective synchronization, resulting in periodic fluctuations detectable through high-precision monitoring arrays. And these findings inspire theoretical models proposing that the organisms may generate or utilize microscale electric potentials within their mineral-integrated bodies, enabling them to interface with electromagnetic gradients to regulate internal energy distribution or coordinate movement across vast distances through field-based signaling mechanisms. And if such mechanisms exist, they may represent an entirely new form of biological communication not dependent on sound, light, or chemistry, but on resonance, alignment, and electromagnetic coherence, enabling swarms of organisms to act in concert far beyond the sensory range of conventional life. And as researchers explore these models, they begin to consider the possibility that the organisms may possess distributed intelligence wherein decision-making emerges not from individual cognition, but from the collective. Alignment of resonance networks, producing coordinated responses to environmental fluctuations through group-level dynamical processes analogous to neural networks but formed from minera. L. Biological structures instead of neurons and synapses. And if validated, this would represent a profound expansion of the concept of intelligence, demonstrating that cognition can arise from the synchronized interaction of mineral matrices and geophysical fields, enabling complex environmental recognition, behavioral adaptation, and collective decision-making in a biological system, radically different from traditional evolutionary lineages. And as discussions progress into the implications of such cognitive systems, scientists begin assessing whether the organism's contact with the submarine hull could represent a form of investigative behavior arising from distributed environmental recognition processes wherein the vessel's artificial field distortions triggered a localized decision pathway, prompting the organism to assess the anomaly through surface traversal and resonance mapping. And if so, the footsteps become part of an intelligent, environmental monitoring system, reflecting not randomness or instinct, but a structured exploratory response consistent with the organism's role as a stabilizer, regulator, or sensor within the deep ocean geophysical network. And this interpretation suggests that the organism's contact with human technology may increase in frequency as exploration equipment penetrates deeper into previously undisturbed trench zones and introduces anomalies into field environments to which the organisms are highly sensitive, potentially resulting in more frequent interactions as the organisms attempt to interpret or compensate for disturbances introduced by artificial stems. And this possibility prompts the development of new submarine protocols designed to minimize sudden field disruptions and reduce unintended interference with deep ocean biological geophysical networks, acknowledging that human presence may alter the natural resonance environment of trench ecosystems with unknown consequences. And as these protocols are drafted, scientists recognize that humanity now stands at the threshold of an entirely new relationship with Earth's deepest environments, requiring unprecedented caution and respect, as further intrusion into the abyss risks destabilizing delicate resonance systems that may have regulated the planet for millions of years, long before human emergence. And as the extended report reaches its conclusion, it affirms that the initial footsteps recorded on the submarine hull represent the first verifiable contact with a resonance-based biological system operating at planetary scale, and that the organisms responsible may form an integral part of Earth's geophysical behavior, shaping seismic stability, electromagnetic distribution, and deep ocean chemical cycles through continuous interactions between their mineral integrated bodies and the dynamic forces of the planet. And the report warns that future exploration must proceed with careful understanding that humanity is no longer studying a passive environment, but entering an active geophysical biological system, whose complexities extend far beyond the limits of traditional science, and whose guardians or inhabitants may have evolved in synchrony with Earth's internal rhythms, forming a living architecture in the deepest parts of the ocean, whose presence remained hidden until the moment their footsteps crossed the hull of a passing vessel and revealed their existence to the world. As global research initiatives converge toward a unified interpretation of the resonant organisms believed responsible for the footsteps detected on the submarine hull, the scientific community enters an unprecedented phase in which decades of geophysical anomalies, chemical irregularities, deep ocean acoustic distortions, and unexplained electromagnetic fluctuations are re-examined under a single cohesive framework, suggesting that the deep ocean trenches may host a continuous, living infrastructure shaped by mineral-integrated biological forms that have co-evolved with the planet's internal processes across geological time. And this framework rapidly transforms from theoretical speculation into a structured discipline, as cross-validated evidence reveals that the organisms exhibit not only locomotor capabilities at pressures far beyond the mechanical breaking point of organic tissue, but also consistent patterns of environmental engagement that align with rhythmic geophysical cycles, indicating sensitivity to mantle wave propagation, resonance shifts, tectonic microcompression patterns, and deep electromagnetic drift. And these alignments demonstrate that the organisms exist within a domain governed by physics, not typically associated with life, and yet their behaviors consistently express biological hallmarks, including movement, environmental assessment, structural adaptation, and coordinated interacti, on across wide geographic zones, suggesting that their form of life does not represent an exception to biological principles, but rather an expansion of them, shaped by evolutionary pressures entirely distinct from surface ecosystems and the Enicares and Bayer. Extensive integration of mineral crystalline matrices within their structure likely arose through processes that selected for pressure stability and energy conduction rather than flexibility in biochemical metabolism, enabling the organisms to withstand conditions that render ordinary biology inert, and allowing them to convert environmental forces into functional energy through mechanisms that resemble piezoelectric transduction field, resonance absorption, crystalline charge alignment. And these mechanisms appear to allow the organisms to act as both energy harvesters and environmental stabilizers, converting vibrational energy into internal structural reinforcement, while simultaneously redistributing geophysical forces across regions of the trench system, thereby contributing to long-term geological equilibrium, and as datasets accumulate from remote sensor arrays deployed across every major oceanic trench, researchers identify broad patterns of synchronized resonance activity consistent with population-scale environmental monitoring, in which the organisms collectively interpret field gradients, pressure fluxes, and seismic signals in real-time, adjusting their positions to either absorb or diffuse energy concentrations and prevent instability. And this discovery leads to the realization that deep ocean geophysical conditions may be shaped not solely by tectonic processes, but also by the continual activity of these resonant lifeforms, whose presence dampens or redirects seismic stress, relaxes localized instability, and alters mineral deposition patterns, creating an environment in which geological volatility is subtly moderated by biological processes that have evolved to integrate directly with the planet's physical dynamics. And further confirmation of this framework arrives when researchers identify century-scale patterns in hydrothermal vent output correlating with previously unexplained periodic anomalies in deep ocean resonance readings, suggesting that the organisms may influence vent behavior by modulating sediment structures and mineral flow pathways, creating a dynamic stabilization system that permits a balanced exchange of heat, minerals, and chemicals essential to the deep ocean environment. And this role extends beyond local ecological effects, implying that the organisms to participate in regulating the broader oceanic chemical cycle by influencing carbon sequestration processes, mineral transport pathways, and the release of trace elements critical to sustaining microbial ecosystems. And through these cumulative interactions, the organisms appear to function as integral components of Earth's long-term environmental equilibrium, forming a biological geophysical continuum that has operated unseen for millions of years and is only now becoming visible through the advancement of human technology capable of detecting subtle field distortions and pressure signatures that betray their presence, and the recognition that the HT and Flash SA organisms may form a planetary scale, regulating network forces, a re-evaluation of Earth's evolutionary history, suggesting that life may not have emerged solely as a phenomenon of surface chemistry and sunlight-driven biochemistry, may include parallel evolutionary trajectories shaped by the planet's deep interior energy flows and mineral structures, creating multiple coexisting biospheres, each adapted to distinct environmental domains and interacting with their resistant surroundings in ways that extend far beyond traditional ecological models. And this broader evolutionary view reveals that the deep ocean biosphere may not merely coexist with geological processes, but actively shape them through a continuous feedback loop in which biological activity influences tectonic stability and tectonic fluctuations, in turn guide biological behavior, resulting in a self-regulating system that has maintained long-term environmental homeostasis across eras of planetary change. And within this expanded understanding, the footsteps recorded on the submarine hull become more than the initial evidence of an unknown species. They become the first detectable symptom of a vast, hidden architecture of life operating in perfect synchrony with the Earth itself, and the organism's contact with the hull likely represented its attempt to interpret the artificial disturbance introduced into its sensory domain by the vessel's electromagnetic and pressure emissions, revealing that human presence in the deep ocean is not merely an exploration of inert terrain, but an intrusion into the functional space of a living planetary system. And this realization necessitates new protocols for future operations. As human technologies increasingly penetrate regions inhabited by resonant organisms, whose stability and survival depend on the continuity of geophysical ensemble. Rhythms now subject to disruption from artificial sources, and researchers advocate for the development of deep-sea equipment, specifically engineered to emit minimal field distortion to avoid interfering with the organism's sensing mechanisms and locomotor pathways, and to prevent accidental destabilization of trench ecosystems, whose equilibrium may depend on uninterrupted biological geophysical feedback. And as efforts proceed to implement these protocols, collaboration expands across fields, including neurophysics, evolutionary geology, planetary sciences, and mineral biology, leading to new theoretical constructs describing how cognition and environmental awareness might emerge from mineral, integrated systems rather than neuronal architectures, providing a conceptual framework for understanding how distributed intelligence could arise from resonance-based information processing and be expressed through coordinated movement, pattern recognition, and adaptive environmental interaction, performed by organisms lacking traditional sensory organs, yet capable of interpreting complex geophysical data and responding with structured, coherent behavior. And this theoretical data, the Foundation offers a compelling explanation for the organism's behavior during the hull encounter, indicating that its locomotion across the submarine surface was not random or instinctive, but an expression of environmental interpretation conducted through resonance mapping, a biological response to information, rather than a reaction to threat or curiosity. And as this interpretation solidifies the event, becomes recognized as a landmark in the scientific understanding of life as it expands beyond organic biochemical constraints into the physics of matter and energy, revealing that life can emerge in any domain where structured interaction between environment and organism allows pattern formation, energy utilization, and adaptive response, regardless of whether the underlying substrate is cellular tissue, mineral crystalline frameworks, or a hybrid combination of both, and the final global consensus. Report asserts that the resonant organisms represent the most ancient and most deeply integrated biological system on Earth, predating many shallow biosphere lineages and operating as a stabilizing infrastructure essential to the planet's long-term geological and environmental continuity, and that their discovery marks the beginning of a new era in which humanity must redefine its understanding of biology to include systems governed by field dynamics, environmental resonance, and mineral-integrated evolution, extending the concept of life into realms previously considered beyond its reach. And as the scientific community closes the final volume of the investigation, it acknowledges that the identity, morphology, full behavior of the organisms remain unknown, and may remain so until new exploration technologies allow direct observation. But the existence of the footsteps remains the irrefutable first message from the hidden biosphere, a signal that life extends downward into the deepest structures of the planet, forming a continuous living architecture woven into Earth's foundation and sustaining its rhythms across geological timescales. And thus, the event marks both an ending and a beginning, the end of the belief that the deep ocean is lifeless and static, and the beginning of humanity's recognition that the abyss is alive, resonant, and aware, and that beneath the crushing pressure and eternal darkness there exists a vast unseen world, whose footsteps across a steel hull were the first whisper of its presence, after an eternity spent hidden in the deep. We upload new videos every single day, so make sure to subscribe and turn on the notification bell so you never miss what's next. If you enjoyed this video, don't forget to leave a like, it really helps the channel grow. Tell us in the comments what you'd like to see next. Your ideas might be in our next upload. Thank you so much for watching and for being part of our community. Stay tuned, stay curious, and we'll see you in the next video.